Hello subscribers and guests of the channel, welcome back, and this is the second lecture in my Maths A-Level and IB series, and it will be devoted to integration. Please don't forget to subscribe to the channel, because this tells me how interested you are in what I'm doing and encourages me to do more videos. Let's begin. So today's main topic is integration. As you can see, here I'm already prepared with my blackboard. So let's start. First of all, what is integration? Many of you probably get scared seeing this sign. This is a typical integral sign. So what to do with it? This first part of the lecture will be devoted to basic integration and definitions, because it's very important to understand what you are dealing with, what you are actually trying to do here. So integration is the opposite action towards or to differentiation. So you can take a derivative, this is dy over dx, and if you have a function, so let's imagine that you have f from x, which is a function from x, you can take derivative, so you get dy over dx, which is the same as f dash from x, and if you want to go backwards to that function, you need to do integration. So integration is the opposite action to taking derivative, and that's the first thing that you need to know about integrals. Today's lecture assumes that you already have some understanding about derivatives. You know what it means, you know how to take simple derivatives, and if you don't, then a bit later there will be the course on derivatives here, so I will add the link to the video and you will be able to click it and join derivative course first. But now let's continue speaking about integration. The second part that you come always across with is sign d something, dx, dy, dt, or anything else. For example, you have an integral from, let's say, 2x and then dx. What does this dx mean? Well, many students forget writing this dx. Many students don't understand, but it's simple. It means that this function was differentiated relative to x. So it means that when you are taking the integral, your main variable is x. Usually most of you will not really need this dx during the first year of a level, but during the second year, when we study substitution method, dx will be important. So dx means that x is the variable, everything else you treat as constant. Another common question that many people have is about c. What is c? Why do we write it? Do we really need it? And so on. So for example, when you have this integral of 2x dx and you want to solve it, the solution will be x squared. We're going to do later to discuss why is it x squared, but then plus c. So what is c? C is a constant which is written at the end of indefinite or undefined integrals. Undefined integrals or indefinite integrals are those without numbers at the top and at the bottom of the integral sign. So what is c? Let's imagine that you want to take a derivative first, and you have x squared plus 5. So you want to differentiate this function. If y is x squared plus 5, dy over dx will be 2x. Again, I assume that you know that constant disappears, because derivative of the constant is just 0, so you can say 2x plus 0, technically speaking. But what if your function is x squared plus 7? So where does this 7 go? and again dy dx will be 2x plus 0. So irrespective of what constant is at the end, that constant disappears and becomes 0 at the derivative. So if we want to take an integral, so we want to take a backwards movement or action, and we want to integrate 2x to give us x squared, so we're going backwards and integrating. We do not know what constant there was, and if there was anything. Maybe we just have differentiated x squared to get 2x, and then we can return by integration straight backwards. But maybe y was x squared plus something, like plus 7. Do we know whether it's 7, 5 or 3? No idea. So that's why if that function was differentiated to 2x, backward movement will give us the integral, will give us x squared plus some sort of constant which is not known to us, which is impossible to identify unless you know specifically or you are given information about how this function behaved or through what points it went through before. Now, after all preliminary issues have been discussed, we can move on to integration itself. Integration has in a level and AB program several rules. So there is basic integration, which we are going to do now. So let's call it base. Then there will be several special ways or methods of integration, and those methods will include substitution. Let's write it here. So substitution. Then partial fractions, integration by parts, there will be also ln and reverse chain rule method. So today in this lecture I'm going to cover the basic integration methods, but then of course we're going to cover the rest. So let's begin. If you have integral of ax power n relative to dx, so differentiated by x, the rule is that this whole thing will be x power n plus 1, so the power is raised by 1 because it is opposite to taking derivative. When you take derivative, the power goes down by 1, and now you can raise it by 1 back. And then you divide coefficient a by that new power, by n plus 1. And after you've done, you write plus c, of course. So let's have an example. Integral of 5x power 3 dx. What will it be? X will be in the power 4, so 3 plus 1 is 4, and then 5 will be divided by that 4, and plus c. So this is one of the easiest examples of integration. This works for every and any power, but not minus 1. The problem arises when x is in the power minus 1. Integral of, let's say, 5x to the power minus 1 does not work at all in this standard method, because you will get x to the power 0 and then 5, you'll have to divide by 0. This raises a lot of questions, and that's why it is not integrated using this method. Overall, and you must learn it, that the integral of x power minus 1 is the same as dx, of course, is the same as integral of 1 over x dx, and it will be ln on natural logarithm from x plus c. Sometimes people add modulus here. So ln modulus x plus c. In all other cases, this standard method works. For example, if we have integral of, let's say, 6x to the power minus 2/3 dx, no problem. We can integrate it. We can raise the power of x by 1, minus 2/3 plus 1 will be 1/3, and then we will divide 6 by 1/3. Of course, this requires simplification. 6 divided by 1/3 will be the same as 6 times 3, so it will be 18 x to the power 1/3 plus c. I hope this is clear for now, and we can move on to other standard questions and mistakes. What if you have integral of, let's say, just 5 dx? What is this 5? 5 means that there is no x, but we can add it, we can write it as integral. Let me move it to the side here. So as integral of 5x to the power 0 dx, and then use the same and usual our rule. So that will be x to the power 1, because the power raises by 1, and then 5 over 1, which will be then already without integral because I have calculated it, which will be then 5x power 1 plus c. So overall the rule is that if you have an integral of a dx, a means any constant, then it will be a x plus c. And here is where dx plays a role, because dx tells us what is the variable or what should be the variable. For example, integral from dt will be t, and integral from 2 dy will be 2y, because the letter after d tells us what letter we should put there. Of course, plus c everywhere. Now addition and subtraction rule. If you have integral, let's say 2x power 3 minus 3x plus 7 dx, this can be broken into 3 different integrals, the same way as with derivatives. So you get integral of 2x cubed dx minus integral of 3x dx plus integral of 7 dx. So if you have plus or minus, the function can be broken this way, so that you can have three simpler integrals. However, this is not possible in case of multiplication or division. So if you have something like integral of x sine x, this is in no case whatsoever integral of x times integral of sine x. This does not work this way. So you cannot break two different integrals, division and multiplication. This is one of the common mistakes that people do at the start of their integration learning. Let's now move on to a bit more difficult example to recap all the information we've learned so far. For example, we have an integral of 2 over root x plus 3x power minus 6 plus 7 and maybe minus 1 over x dx. So this is an integral which consists out of 4 monomials, like 4 parts. So part 1, part 2, part 3 and part 4 before dx. So we have a right, since between the parts is plus or minus, we have a right to break it into several integrals. It will be integral of 2 over root x dx plus integral of 3x power minus 6 dx plus integral of 7 dx and minus integral of 1 over x dx. What to do with it? Well, integral of 7 is easy because we've just studied it, and it will be just 7x. Integral of 3x power minus 6 is also straightforward because we raise the power. It will be then minus 5 because minus 6 plus 1 is minus 5, and we divide 3 by minus 5, so I can write it as minus 3 over 5x power minus 5. But the first and the fourth parts are a bit more difficult. Here we need to remember that integral 1 over x is ln x, so we can write it minus because in front of integral there was minus ln x. But what to do with the first one? Well, the first one is a division, but thankfully we can make it as a certain power of x. Root x is x to the power 1/2. Since that root x was at the bottom of the fraction, it will be rewritten as x to the negative half. So it will be 2 times x to the power minus 1/2. I'm sorry, today it's very windy. I'm not sure if you can hear this wind, but if you do, yes, we have a hurricane here. So therefore 2 over root x can be rewritten as an integral of 2 times x to the power minus 1/2. So after we can rewrite it as in that form, everything becomes easier since we can integrate this using our normal rule. So it will be x to the power 1/2 and then 2 divided by 1/2. It will be the same as 2 multiplied by 2, so it will be 4. So therefore the answer will be 4x to the power 1/2 or 4 root x minus 3 over 5x power minus 5 plus 7x minus ln x and plus c. So we have done a typical integral of the first year of the A-level, which is considered to be not so easy but not so awful. The next part we will discuss definite integrals, but this will be already in lecture 3. I hope you have found this video useful and have learned something new for you. Please don't hesitate to write any questions or any comments to this video, and see you soon at the next lecture. Bye bye everyone.